Hello, everyone. This is a tale of two workflows. I am your storyteller, Pete Cheslock. You can find me on Twitter. I don't think Dickens had Twitter, but I do. So it was the best of times, and it was the worst of times. The age of wisdom. I hope my GIFs are animating, otherwise this talk will suck. And there were definitely some good ideas. It was the age of foolishness. This might age me, actually. This is old, back to Wayne's Brothers. We had some not so good ideas, many of which I'm going to share with you today. That's pretty much where the Dickens ends, because trying to get a talk to look like Dickens is like impossible. So anyway, I'm Pete Cheslock. I currently work at Dyn. Who's here as a Dyn customer? Dyn, Dynamic DNS. All right, so for those of you that may not know, Dyn DNS, traffic management, DNS, email, message management. I've got the throwback logo up there. That's the old school Dyn DNS logo. Previously, I had a company called Sonian. It was an email archiving company, one of the really early Opscode, Chef customers. We were definitely one of the earliest on hosted Chef, because we would break it often because we would just push too much traffic to it. Anyone here heard of Sensu? So Sensu came, probably more people have heard of Sensu than Chef, or than Sonian, but Sensu came out of that company while I was there. So I always like to have a disclaimer, because I'm going to talk about two specific different workflows at two different companies. So real companies, real workflows, really bad or good choices, depending on your viewpoint. And so you shouldn't attempt these at all. I might anger people. That's cool. If you need a hug, I'm here. I like hugs. And I'll give you a hug afterwards if I upset you. My double disclaimer is, for all the love of DevOps, please, 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 don't cargo cult this. Don't just take it, kind of blindly apply it to your infrastructure, because things will go badly. So I think there's bits and pieces that might be interesting to everyone here. And I think the biggest part of this talk is talking about the cultures within those companies that kind of brought about these workflows, because I think that's the biggest part. Is my culture is different than yours, and my infrastructure is different than yours. So the way in which we use those tools are going to be a lot different. So what am I going to do here today? We're going to talk about basically 4+ years of Chef, my time with Chef. And a lot has changed over that time. And when we started with Chef, there was no roles, for example, or I don't think there were data bags at the time. So we're going to talk about these two specific companies, tools we used, tools we built, the requirements we worked with, and then basically how things turned out and what we learned. So now, we did some weird stuff. We did some crazy stuff. There were reasons. There's always reasons why we do the things we do. But I think the key thing is how you use Chef is dependent on your workflow and your infrastructure. I would bet everyone here probably uses it slightly differently, which is great. That's why we like Chef. So, but what I'm going to do is try to do my best, at least, to point out places where our design decisions were actually based on biases of the organization and the culture behind it there. So biases, they rule everything around me. So Chef is, I guess the best part about Chef is it's extremely flexible and allows you to do pretty much anything you want. And then the worst part about Chef is it's extremely flexible and allows you to do pretty much anything you want. So I see on the mailing list and IRC and everywhere else, everyone's like, how do I get started? What do I do? Where do you even start? And as a new user, it's fairly overwhelming, right? So, roles, good, bad, I don't even know. Hopefully this animation is popping up. OK, cool. And when I started at Dyn, a lot of people have never used Chef. They're not Rubyists. C++ programmers, and so you kind of telling them all these cool new things, and it can be just a lot to kind of take in. So we're all using Chef because we don't want the tool to dictate the usage. We want something flexible. John Cowie, I don't know if anyone went to his talk. He said it before. Basically, like the whole purpose of Chef is that instead of building Chef to keep up with infrastructure, it wanted to be modular and pluggable so that it can be flexible for essentially all of our uses. So basically, where you start, you got these cookbooks now. Now what do you do? So you pick your poison, right? You want one big ass repo with all your cookbooks in it. Not that that's a bad thing. Do you want one repo per cookbook? How do you manage your versions? How do you manage your dependencies? The key thing that I'll say is your success with Chef is not determined by this decision point, because hopefully no matter what you do, you're going to change it in the future. You're going to want to improve upon your workflow as your organization matures. So first company up, Sonian, founded 2008, or maybe a little earlier. My dates might be wrong. They were early AWS user. They were a Startup Challenge finalist. I joined in 2009. Again, early Chef user. They were originally Puppet, because it was before Chef. but then moved to Chef. And massive growth over the time that I was there, from dozens of servers to thousands, from just AWS to multiple public clouds. And so the automation of all those systems was like really critical for us because deploying to HP Cloud, deploying to Rackspace Cloud or EC2 or wherever we had to, was difficult. So automation was key. We're spinning up and spinning down systems all the time. So how do we manage those systems, right? You got fork this repo. This is how you get started. So we'd have like our knife RB driven by environment variables for everyone to use, cookbooks, databags, environments. We would put libraries in here, like helper libraries, binary scripts, like whatever we could shove in here. Knife plugins. We didn't ship knife plugins via gems. We just shoved them in here because it works that way. And we used this, and it worked for quite a while without any kind of major issues. But few misfires along the way. The communication at Sonian was pretty high. We had a remote team, so people would chat over IRC or whatever. And communication, like I said, was high because that was like forwarding everything into that one place. So, but business starts picking up very quickly. Speed picks up, the velocity. You have to make concessions. Like, who here has worked for a company that has been moving basically so fast that you're like, I could do A or B, and which one's fastest, right? There's pretty much most people here. So you have to make concessions, and you just have to get things done for the most part. So speed picked up, and mistakes were made. Another interesting thing at Sonian, it's an email archiving product. And when you sell larger deals of email archiving, there's contracts that come in, and they'll say kind of crazy things like, you can only deploy to this SaaS product at these specific times. So our speed of deploying was we could only deploy as fast as basically whatever contract was like most restrictive. So I'll talk more about that a little bit later. But for the most part, what it looked like in kind of the earlier days, you'd have your Chef repo, maybe you'd have a tagged release, or you'd be off master or something like that. Maybe you have 3 customers. The way we broke out our customers was via these different environments, Chef environments, different stacks, full stacks for different large customers. Maybe one customer's running off of head, maybe one's a few commits back. And it works, right? People know where they have to be to do knife cookbook upload A or whatever your running commands are, right? But then, this happens, right? And you get completely screwed because something changed. Someone pushed some code to a different environment at a different ref, and now like nothing works, right? So we had to keep, and we ran all these different stacks and environments because keeping data separate, whatever. So someone pushes a change, maybe they don't notice that they uploaded to the wrong environment, which happened often, and now things are broken, and you're looking everywhere. It just completely sucks, and it's painful. It hurts a lot. So now imagine that environment with 20 plus, or imagine that scenario, I should say, with 20 plus environments. Each one living in multiple public clouds. Each one has a different contracted deployment schedule. Some we could deploy every day. Some we could deploy to like every 3 weeks or every 2 weeks. And some of you might say, well, a system change, that's not a deploy. I'm not changing code. I'm like, well, then you should be a lawyer because my lawyer is different on that one. So how does this really work in practice? Basically, we just push a small change to production. This is before we create any sort of workflow. We'd push like a minor change, and then everything would break terribly because we were basically pushing the infrastructure much harder and faster than we really should have. It was a lot of technical debt from growing so quickly that even the minor things would kind of get us later. And then this is email archiving, so we really need to be up all the time. Customers are sending us their email. We're holding on to that data. We can't drop that data because lawyers get really upset when they're being sued and they're trying to find that piece of evidence in their email. So we have to ensure that the changes we're pushing aren't going to horribly kind of break everything. So this was 2011, I think, at the time. So there was no librarian, there was no Berks. We needed a way to control the branches of code that were going to get deployed out to these systems. So for our deployment, it was kind of like creating every story, like a Jira story or something, would have a branch. And we wanted to get into this cycle of branch, commit, merge, test over and over and over. And we were focusing on pre-production first as a way to basically test this stuff out before we kind of did it with production. So it kind of looked like this. So head on master is what we consider done code. And again, we're talking one giant repo of every asset in there. So roles and data bags and whatever else. And so this is code that has gone through QA regression testing. It's system changes and application code, because in Chef we would say like deploy this version of the application. But it's all gone through like QA and whatever. So all the branches would essentially get cut from here. So so basically, like a new branch, basically how it would work is branch gets cut from master, developer does their commits, developer then merges their stuff into dev, which will upload it to the dev stack. If they, things didn't break, they merge it into QA. Then if it goes through regression testing by an actual team of people, then we merge it into master. So it was basically this workflow that allowed us to start ensuring that roles, data bags, environments, cookbooks, and application code kind of moved together from dev to QA. We actually had a UA, a user acceptance stack as well. And then we would even keep doing that on the way out to production. So like low-risk stacks and high-risk stacks, things like that. So who here loves roles? That's it? Like 3 people? Who here hates roles then? Who's indifferent on roles? I just want to get people to raise their hands. Come on. So production was a bit more complex because we used roles a lot. Again, this is a long time ago. We didn't have people saying, well, we didn't have Burke Shelf. We didn't have a lot of this stuff. Roles are, and are still, I believe, are a great thing, used for specific reasons. And I'm going to completely contradict myself later on in this talk, just so you know. So we use roles a lot. We would use roles to say what you are. So a role is what you are, like this stack, and maybe you have a base role and then a non-prod or a prod role or which cloud you're in, application level roles. And we would do stupid things like put the version of code to deploy in the role. Well, and roles, as you know, are global objects. If you change a role, it's going to go everywhere. And that's bad. But we were basically role dependent. So you might have someone say something like, hey, let me put this small change to one role. And then the inevitable happens is that everything breaks terribly with this one little minor change that went out. So we got burned all the time. And it instead of like move fast and break things, we moved fast and broke everything. So we needed something that, again, 2011 or so, we needed something that could kind of work for today, maybe be flex enough for the future. And so we're like, yeah, let's create a Git branching strategy. And so a lot of people might be like, like, why would you ever do that, right? Because it's not that good of an idea, I guess. So here's the question we were trying to answer. And we thought at the time that this was basically the way to do it. And I'd love to chat with anyone on how you guys manage this stuff because, again, we're all doing different things. But we want to answer the question is how do you version cookbooks, roles, data bags, and your application code, because if your role says deploy X version, as essentially like one bundle of assets, like code assets to deploy. And since essentially all that data was in the Chef repo, we said, well, we can just use Git reference points to say this is the version of the whole environment. So what does that look like? So before we talked about all the code gets tested in QA. It goes through that cycle of to a dev stack, to a QA stack, regression tested by humans, and they make sure everything's good to go. So master, head on master basically, what would happen is during a deploy, because master is the done code as we know, we would cut some branches. We'd cut a release branch, and we'd cut a base tag. So as you know, you can't commit to tags, and so that's basically the starting point. So why would we create a tag? It's basically because code is going to be coming from QA. So master's moving forward. It keeps moving forward. And we want to deploy a stack at basically a point in time. So we would have a tag, in this case, release 2011-701. There is website code has the same version name, and there's backend code that has the same version name. So the next step would be so let's say I want to patch an environment on this release. How do I do that? I can't cut a branch from master because I'm going to pull in like a ton of upstream changes. So that's where that base tag comes in. So if you're an engineer, you would check out a branch from the base tag and then merge it into the release branch. And then if you want to move forward, you're going to move it to master and be done with it. So the next step is another release, right? So we do the base tag and we do the release tag. And the environment would basically get uploaded from this section. And it would operate in the same fashion. After this, we might have these individual commits that we would do. So things that are too lightweight for a branch, even though it's Git, so branches have no cost. But like I want to just push a singular change one file. We might just do a single commit, and then we'll just cherry pick those forward using Git commands. And then lastly, which is if you do crazy Git foo, we might accidentally or on purpose create a branch off of master, but then realize it needs to go back to an old release. So we would then rebase it on an old tag and then squash merge because we had people who really wanted the Git tree to be pretty. So you're probably thinking this, right? That sounds really complex. Who thinks that sounds really complex? Hopefully everyone raises their hand because it was, but we had some Git experts on the team, and we had a lot of tooling around the branching strategy. But I think more than that is, again, as we talk about the chef code and the systems code and the application code kind of all living together, what we were really doing is like we were release engineering, right? So we had a branching strategy, and we had tagging, and we had packaging, right? And we had all these different ways that we kind of control it. And I'm sure real release engineers would tell me I'm completely wrong, because I probably am. So, but at the time, you got to remember, again, there was no Berg shelf, and I wish there was. And some people were using Git submodules, which I would never ever touch for this scenario. But you know, it was overly complex, but the tooling really helped us here. So we actually built a tool to assist us with this called Mission Plus. And what it was is when you wanted to actually push code to a stack, so let's say you're in that release 8.1, whatever, and you want to push to a stack, you would push to this, you know, git push mies, whatever. And you're basically pushing a reference point and saying, hey, push all the code from here up to that stack. And the cool thing on mies and what it would do is, and I don't know how the text looks on here, if it's easy to see, but basically in the middle section there, you see like ref points from like old to new. So when someone pushes it, you click on that. And if I was smart in advance, I would have shown you what that looks like. But when you click on that, it'll show you an actual git diff of like, here's the files that are changing. So what this basically allowed us to do is to say things like who pushed what and when did they push it. There was no more concept of something changed, like things broken and we don't know what changed. I think I thought about it at the time, but I never actually did it. I figured I'd piss off everyone on my team, but I was actually going to remove everyone's upload privileges to the chef server and just have us push to here. If I was smart, I would have done it, and I probably got lazy or something. But the concept here is that we're pushing to, in this environment, you'll see there's a lot of like pre-production stacks that we had. And so if you're a normal engineer and you want to push a new release of chef code out, you'd push to this, and it would upload it. But if you push to a protected stack, and that was any stack that was pretty much production, then you had a concept of an approval process. And the approval process is someone else logs in, and they click the little button that says approve. And hopefully, it's something like this for more games where, you know, before launching those nuclear missiles, they're, you know, turn your key, sir. So 2 people would have to look at that code and hopefully agree upon it. Now, the other way I looked at it, too, was it was a way to kind of slow the roll down a bit on a deploy, because if someone pushes the code and you approve it and it breaks, it's not their fault, it's your fault. Why did you approve it? Did you look at it? Now, if you looked at it and missed something, no big deal, but we were trying to basically push that one. So what happened, right? We kind of had no process, no workflow to a workflow. So it seems like it would work, it would actually work. Not only did it work, but it worked really well. And to give you kind of a concept of how we deployed code, like chef code, and again, chef and application lives together, we had, this would be what we call deploy week, 20 stacks of 20 separate customer environments. We'd upgrade about 4 per night. It would go from like 6 p.m. to 12 p.m. If you were lucky. Sometimes you weren't, and it went much later, even into the morning in some cases. Our deployment schedule was such that we would develop for 2 weeks, we would test for 1 week, and then we'd deploy. So every 3 weeks you're doing this. Every 3 weeks you're burning a week of deploy. It's painful. So that was before, before deploy week, we just deployed all the time. I always make the joke of like, is it still continuous deployment if you just log at all your servers and change shit? If so, we were continuously deploying, like, seriously. So let's see, over the course of about 12 months, as we instituted this process and started going through it, again, we started off and it was deploy whenever, continuously, right? Continuous deployment. Things break randomly because there was little testing and not really much planning. We created this like multi-page checklist for the deploy, and it was like mostly manual stuff. The beauty of that manual checklist was that was all the stuff we automated in the next sprint. So over time, it was like massive checklist getting smaller and smaller and smaller. So again, deploy week, ton of stacks over many days, and hopefully you could get it done in a few hours, to what we call deploy day, which was we would do all of them in that kind of one night time, maybe about 3 hours or so. And then contracts reasons and stuff, we actually moved deploy day to a Saturday. And by at least when I was still there, we got it down to just about an hour. So, I mean, this is a massive improvement. And even though, so the rule that we basically had for deploy day was if you worked, like if you did a deploy on a Saturday, you just took another day off. So, it was great when you could get it, like you were getting those tools better to make those deploys faster and safer, hopefully. So, if you spent an hour on a deploy on a Saturday and you take 8 hours off on a Monday, which is kind of nice. So things got better, and the key thing was deploys were drama-free. We knew exactly what we were deploying. It had gone through all these levels of testing. Now, granted, things happen from time to time and whatever, but all the pieces moved together. They all changed at the same time. We treated data bags, roles, cookbooks, et cetera, all together. And we even got to the point where, as we got better at it and faster, then we spent the time that we were investing on, a week of deploys into actually making the tooling better, so that the support team would do the deploys, or other teams would do the deploys. And really, like, high communication as this was happening really allowed this to work. So, that's pretty much like DevOps, right? High communication, tight feedback loops. DevOps. So, I'm going to ask this question. How many people here maybe think about from time to time what it would be like to have a greenfield opportunity with really anything? But it could be Chef. Like, you're like mired with your normal stuff. So of course, you think about that. Like, what if I could walk into a place and everything that I currently know and do it completely differently? What would you do? So, enter Dyn. Again, for those of you who don't know, or incorporated 2001, we do traffic management, message management, and I joined early last year to run system automation and release engineering for them. We may or may not have called that team the DevOps team until people made fun of me for it, rightfully so. We now call it the DevTools team, which sounds much better, and we stole that title from Etsy, so thanks for that. When I started there, I had, like, during the interview process, and I think sometimes during the interview, companies will tell you one story, and it sounds really nice, and it's like, oh, it's a beautiful green field. I can go out and change the world. This beautiful thing, no historical biases, right? There's no technical debt. Look at that. It's gorgeous. And yeah, that's Windows. There was no Windows, so I just thought it was pretty. And so I thought, like, this would be a great opportunity. I can investigate requirements, try different things out, and just see what happens. But when it comes to technical debt, like, there is always technical debt. So a little story about Dyn. So we were probably a under 50-person company until about 2008, 2009. From then until now, we have about 300 employees. So we've had massive growth. Our customers have grown, massively. It's just growth in every possible place. We had in maybe 2006 to 2008, we probably had 5 sites. We now have over 20 sites for our DNS and email traffic management products. So basically, like, high growth, high speed, so you have to make concessions. And when you make concessions, you incur technical debt. But I will say I was never surprised by anything I saw. It's very common to see a lot of these concessions made during the time. So no big deal. But as I looked to my greenfield, I looked out and I saw something in the distance. I didn't know what that was. There were these silos that were out there. Beautiful, shiny silos. So when I first started, I started going to the different teams, and I started getting to know, what they were doing. So I go to the operations team, and I say, hey, what are you using for config management? Oh, we're using CF Engine. I'm like, all right, sounds good. Is it working? Do you like it? Yeah, it works for us. It does solve this problem. Awesome. Go to one of the engineering teams. Hey, what are you using for config management? Oh, we've got everything deployed with Chef. It's awesome. I'm like, oh, really? Is that out in production? No, we can't get it to the operations team because they use CF Engine. Okay. Go to another engineering team. I shit you not. Hey, we're gonna look into Chef, but it seems too hard, so we're gonna try Puppet. And the last one, NAH, not invented here syndrome. Dyn's been around longer than a lot of these config managements, so they built their own that do kind of similar things. So I got all these beautiful silos. So what did Nathan teach us earlier? Like, how do we deal with silos, right? Blow those suckers up. And I just had to get that gif of his, like, creepy little ding. So we got to break down the silos. So needless to say, when I started there, there was a lot on my plate. The biggest thing on my plate wasn't that delicious burrito. It was to pick a single CM solution and standardize upon it. So to pick a single CM solution at a place that has no config management, pretty easy, right? To pick a single CM solution at a place that is using all of them is slightly different. Like, everyone's not going to be happy with that decision. So I can say that I picked Chef because one of the teams had most of the stuff done in Chef, but I love Chef, so fuck you, that's why. I'm the boss. No, I'm just kidding. But no, there's a lot of reasons that I don't really want to go into because I'm sure you've heard it all week or a few days from this one. But I will say that when it comes to the interesting thing about the different silos, right? So when everyone's using the same tools and you're talking the same language, right? one team had fully deployed their app in pre-production, not in production, because this was Chef and this was CF Engine, and they don't talk to each other. So we had to increase the communication and how we do that by using the same tools, right? So the other thing is we have a lot of engineers, and there's a lot of scenarios where an engineer that I may not talk to and may not interact with could just kind of come to us and say, we have this cookbook and we want to deploy it. And so we wanted a brain dead, easy solution for a CI pipeline. Like literally, code goes in, code comes out. You don't have to know a lot about kind of the underlying stuff of what's happening, and I'll talk in depth about what that really looks like. But the key thing is that if you're a developer, you're not a Chef subject matter expert, and you don't have to be. You write a cookbook, and we basically tell all of our developers, if you write an app, you got to bring the cookbook with it. And so they bring it together and just kind of drop it in the pipeline. And and it started working well. So there's some hard challenges when it comes to the service that we provide. So one of our largest services is Enterprise DNS and Traffic Management Service. So everything is a fucking DNS problem, as everyone reminds me whenever something breaks, and they always joke and like, aha, Pete, everything's a DNS problem. So it's really frightening to make changes. It's scary. Now, if you have lots and lots of testing, it's not scary. So that's where we want to get to. But when you have a massive chunk of the internet that is depending on you to be running, it's scary. And it's obviously got to be running all the time. So we have to do this workflow, and we have to be able to push automation without breaking everything. So this is animated GIF. This is BGP monitor watching as routes are getting withdrawn from a bunch of routers. I'm not going to say who this company is. It doesn't matter at all. But this was an eye-opener for me when this incident occurred, because basically what happened was it was an automated change to a bunch of routers that caused the routers to lock up due to a bug in the router software, because bugs happen. So this caused a massive outage in global internet services. So we had to build in necessary gates and levers and have a lot of controlled deploy options. So earlier in the talk, when I said I'll always kind of point out the reasons why we made the choices we did, literally, this is the reason why. I don't want to be that person. This scares me for something like this to happen. So this was like a 30-minute outage, kind of global internet. So people are like, well, what's the scope? How bad are you talking, right? How bad really would this be? So what's the first thing you do when something breaks, right? You go immediately to Twitter, and you bitch about it on Twitter, because they're listening to you, man. They're totally listening. Well, yeah, that's not going to work, because Twitter's going to go down. So, all right, no big deal. I want to buy some beautifully crocheted awesomeness from Etsy. Nope. I need to find some animated GIFs for my awesome PowerPoint. That's going down. I might need to listen to music, because I'm kind of depressed at this point. That's not going to work. I might actually want to get work done, as odd as that may seem, but that's not going to work. And then there's these two sites which have a fair amount of traffic that also go through them that they depend on us. And so, yeah, that's pretty much it as well. So the scope is massive, and we are stewards of our customer traffic. So we really take this shit seriously. I mean, we're very cautious people, because if I have a bad day, you all have a really bad day. And that would be pretty bad. So this is, again, the scope of the impact of how we push our changes is the reason this whole workflow exists. So some of the initial challenges, we have a lot of FreeBSD. Any FreeBSD fans in here? All right, good stuff. Are you also using Chef on FreeBSD? You will soon. Let me show you more. So another thing, change is hard to unknown systems. So we have a lot of systems that have been out there for a while, varying states of config. We need to bring them into kind of a single state of configuration. So the other part too is when you deploy to unknown systems, you bring in dependencies. And I don't want dependencies, because dependencies mean things that I may not have tested getting onto the systems. And so I don't know what it would be like. I don't even know if you can install Chef from ports. Probably it's old version, but it would probably look something like this. Because it's going to pull in a ton of stuff. And I mean, I don't really know FreeBSD that well, but I'm assuming there's better ways to figure that one out. But the key thing is that I don't want external dependencies. So enter the Omnibus. Who here uses, who here uses the Omnibus client for Chef? I think it's pretty much everyone at this point, right? Does anyone use Omnibus for other packages other than just Chef? Built their own Omnibus packages. So a few people, cool. So if you don't know what Omnibus is, it's basically like the giant kitchen sink of code. So it's in the Chef example, it's going to compile Ruby, all the Ruby dependencies, all the gems, and it's going to put it in one big bundle, and it's going to put it in opt whatever. So We love Omnibus. We have FreeBSD, but we also have other OSs out there. And having a single package kind of built from the same source that works across platforms is a huge win for us. So awesome work in the community. Scott Sanders, who works at GitHub now, wrote the initial proof of concept to get an Omnibus to build on FreeBSD. Brian McClellan, who was here somewhere, but he helped and worked with me to actually get our code and build up into upstream. And Seth Chisholmore and a ton of other people from Opscode. It's like straight up, this is like community awesomeness. They had no financial obligation to support FreeBSD, and it's like supported like that. But it's there, like you can curl bash it and download it. So if you are using FreeBSD, if you're using FreeBSD 9, because that's all we have up there so far, you can grab the Omnibus client. It totally works, and it's generally awesome. So FreeBSD's problem solved, cool. We start deploying Chef to the nodes. We create a base role. And because, roles, like last talk, right? Roles are totally cool. We're going to create a base role. And it's just going to have a run list of items. So I did learn my lesson from the last place to not put a ton of shit in the attributes on your roles, because that will screw you over later. But just to have a run list, something simple. A role is what you are, and the run list is what you do. About a month or so later, we wanted to change the run list. And now we're in a situation where we have a global object that if we change one thing, it changes everywhere. And that is scary. So we basically do like a wrapper cookbook for a role. It's a role cookbook. And it kind of looks like this. You just got a bunch of include recipes. We'll also might set and override attributes here for depending on environments or whatnot. But I guess the real bonus here, how many test kitchen users in the room? Cool. So the real bonus to this one is any person can clone a role cookbook and basically run a test kitchen against it with the different suites, because again, we have different OSs out in play. And also have all the server spec testing along with it. So that way you can basically say, I want to make a change to this role, server spec, spin it up, it does all its fun stuff, and it runs a test kitchen spins it up, runs a server spec test at the end, and you don't have to deal with like roles, because like where are your roles? If you don't have a chef repo, right? They're somewhere else, and you'd have to pull them in. So now I'm not going to get into roles versus no roles at all, because this is pretty much the only outcome, right? You're either pro role or anti role, and I kind of fall in the middle somewhere. So in this case, I'd get killed by these people. But so I love roles, I really do, and I think you can be really successful with roles. But again, my infrastructure is different than your infrastructure, than yours, and yours, and yours. So so we just don't use them. Now our pipeline supports roles, and someone could actually send us roles into the pipeline, and we're good to go. But we just pretty much don't tell. We just don't tell people we have roles. They don't know they exist. So we do wrapper recipes. We run the community cookbooks, and we just wrap on top of it. We really like that model because it's pretty much the same as our wrapper role. So like our Dyn CI recipe, anything that's a wrapper is just Dyn underscore the thing. So when Jenkins did a big refactor from 1.0 to 2.0, all we do is we just refactor our wrapper and set the metadata with the version correctly, and good to go. So another interesting bit is something we talk about a lot internally at Dyn is this circular dependency. And I always thought it was kind of a cop-out for like, well, we don't want to do that. We don't want to use this hosted service because it's circular dependency, and I just thought it was a cop-out. But what it basically means is, as I showed in the scope of bad slide, is we run DNS and traffic for a lot of customers. Opscode/Chef is one of our customers. So we noticed when we were basically using the Chef full template to bootstrap a node that you're hitting, you're curl bashing from the Opscode site, right? So we never want to be in a situation where if we're having a major issue, we can't get to the thing to get the thing down because we're having an issue, and again, circular dependency. So so again, we start storing these Omnibus client packages locally. But then we started like digging into it a bit, which is super dangerous to do because you find a lot of stuff. So where are the community cookbooks stored? They're on GitHub. And community.opscode.com. And who does their DNS, right? So we basically created an organization. It's called our Cookbook Repo on our Chef server. Because again, we don't use hosted Chef, right? You got to buy Enterprise Chef or open source, I guess. But anyway, we create a repo, and we grab the community cookbooks, and we just shove them in there. So that's what we did initially. We actually then moved into GitHub Enterprise just for visibility reasons. So it really allowed anyone to see what cookbooks were there. But it also, we would run short-term forks. So while we were waiting for an upstream change, we would just run our local forked version. But the rule was try not to edit them too much, just because just use the wrapper recipe to do a lot of your editing. So we want to remove the humans from the equation because humans make bad decisions. And granted, humans are going to write the things that are going to do this stuff. But So we want testing, and we want testing like as a first-class citizen. And I said to myself that if I force testing as a requirement or just stress it really early, then people won't know there's another option. And like a lot of the developers, like they don't know that they shouldn't ship their cookbook with tests. And it's awesome because they ship their cookbook with tests. So we use Food Critic, Chef Spec, Rubocop, Serve Spec, all during the chef run. It's all automated process. Anyone here use Thor SEM version? Yeah, if you haven't used this, Riot Games, I think, created this one. Basically, this automates our versioning and Git tagging. So humans don't touch the version numbers. They basically tell what cookbooks to update based on the commit messages. So I'll show you what that looks like. So this is a little snippet of our Jenkins run. Chef Spec completes successfully. So it's going to basically tag a version, which is a tag in Git, which is nice. And it will then upload it to our cookbook repo using Berkshelf. So make sure we grab that cookbook and all of its dependencies and put them on the cookbook. Now, if you patch as default for us, if you want a minor or a major, you just do like hashtag minor or major in your commit message. So we're trying to speed up the iteration to master. And for a developer, it's cut a branch, make changes, test, go into Jenkins, and then get it to master. Master for us is not production, where these are two totally separate things. We've separated development and deployment in two totally separate bundles. And so development's happening at this incredibly fast rate. And deployment's happening just a little bit slower because, again, bad things happen when you move too fast. So how does this work for us? Pretty well so far. As the dev tools team, we've kind of evangelized Chef internally. So we're the product owner. People ask us questions. They come into our chat rooms, and we help them out. We give training. We give mentoring. We bring Chef in, Opscode in to do training themselves. And the key thing is that we're not PR, like code reviewing people's cookbooks, because I'm not the app owner. I'm not going to say how the cookbook should be written. It's basically trying to enforce it via Jenkins. So if there's like a custom food critic rule that we want to say don't use this like chef primitive, we could put it there and enforce it. So like I said before, like this is awesome, right? Cookbooks came to me with tests. That blows my mind in an awesome way. Test Kitchen and Berkshelf, we use that all for local development. Obviously, we were using Berks 2 because Berks 3 was not released yet. So because of that, we use Berks 2. There's no site. We don't have site Opscode. We don't use Opscode because we do whatever circular dependency. So we created a simple API. If you're still on Berks 2 and you're not upgrading, which would be silly because Berks 3 works and it has an API, so this is pretty much kind of going away. But we have an API. We point Berks 2 to it, to all of our vendor cookbooks. So the real trick is how do you get this stuff out to production? So we might need to push to a single node in one site, a single node in many sites, single node in every site, single node in region. I mean, it's like every possible deploy scenario because, again, we need to be very purposeful how we ship code so we don't, basically like break the internet. So what we do is we represent a chef organization in Git using the Berks file as a single source of truth. So as you can see in this as an example, here's a bunch of cookbooks with version lock equals. And Jenkins will basically take this file and it will do the dependency solve, and we create an environment locks out of that. So we want this to say like what production should look like, these versions of cookbooks. So I had said we don't use roles because they're global objects that can't be versioned. We have Thor SEM that auto bumps the cookbooks, and then we know that we want to run a node in production in an environment with version locks, and we want those environments to be kind of created in an automated fashion and not touched by human hands. Right? They're immutable environments that get created and uploaded to servers. So I asked this question last year. I was like, I had no idea, like, what's the max number of environments you could create? Because what I wanted to do, and the answer is basically like probably a lot. I'd never tested it, but probably a lot was good enough for me. So we've been using Thor SEM to version our cookbooks. Why don't we version our servers too? So this is a snippet of code where Thor SEM version is basically creating a tag release for the production deploy. We then have some code that will convert the Berks file locks, the solve basically, into an environment file that we then create and upload to the server. So this is a bit of old code. It's for Berks 2, and it doesn't even include the lock stuff. But it just kind of gives you the gist if you're Ruby-minded of basically like create an environment object, use the Berks libraries to solve, get the dependencies, shove them into an environment, and then write it to a file. What's awesome about this is that we can see every tag in the Chef repo is like what that version on the Chef server environment is. So you don't have to have access to the Chef server to know what versions are out there, because it's all in Git. So what does this actually look like? Because this might seem weird, and it totally is. But so we basically have every node lives in an environment. And the environment in this case is the real environment it lives in is something called 1.4 latest. It's this concept of a moving release. Thor SCM can do pre-release and patch and minor. It follows the Semver format. The default option for deploying to production is a no-op, right? We don't want changes to just randomly go out there. You want to be purposeful with it. So what does that mean? So you make a commit, deploy my MyFace Cookbook 103. And as you notice, Jenkins spit out an alpha release. So OK, I want app2 to test that environment, that cookbook. So I flip that node. John Cowie wrote a great tool about flipping nodes. We flip it over to there, do another commit, overwrites 1.4 latest. We flip the node back. And if we want to do a bigger release, like a major, we create a 1.5. And same thing, flip the node over there. Good to go. So I'm running short on time, so I'm going to like fly through pretty much all this. We basically version our data bags, which is either awesome or insane. And if you want to know more, find me after, and I'm happy to talk about it. So basically, we version our data bags crazy because data bags are global objects, and global objects are scary. So we don't do that. So I'm going to fly through all this stuff because I want to get to basically the premise of the talk is that it's flexibility, right? We use Chef because it's flexible. We use Chef that allows us the flexibility to create a workflow like this for our very specific environment. So that's the point. The tool does not dictate your infrastructure. It's the other way around. So we're all at different points in this line. We're all at different stages of improvement along. What we have today is definitely not perfect in any stretch of the imagination. It's a massive improvement where we were at. And on communication, all the good things have happened because of it. And I don't think it'll ever be perfect because that's the thing that drives me to want to make it better. Every place I go, I'm like, people are like, oh, we've got this great workflow, and we'll look at it, and eventually you just kind of look at those things and go, no, we can always make it better, right? You can always improve upon that stuff. So my biggest thing is that it's totally OK to be a special snowflake, right? Your environment is a special snowflake. You have all of these organizational biases and company culture, your unique requirements and operational, expertise that is how your environment gets created and managed. So I think people might disagree with me, but I don't think there's a right or a wrong way to use this tool or many of these types of tools because there's just like your way to use it. So I say you should embrace your special snowflake uniqueness and be a special snowflake. So thank you very much. You can find me on, like I said, Twitter or email or whatever. And yeah, thanks a lot.